Yeah. Thank you. So yeah, I'm Thomas. I work here in Utrecht at High Street. You might know us as Touch Wonders. So Touch Wonders is an app agency, and since a year or two we're making our own product. High Street is an e-commerce platform for mobile apps. So this is the title I suggested to the Cocoa Hat organizers a few weeks ago. They changed it to this because they probably thought I was going to talk about my own stuff all the time. And they're right. Sorry. So this is BrightFutures. It's an open source project on GitHub, and it's a simple futures and promises library for iOS and OS X written in Swift. At least that's what the document says. So before I talk about what it is and more in depth, I just want to show it to you. It's going to be, everything is going to be in Swift, but Swift is out for almost a year now, so we're all doing Swift, right? So lots of Swift code. I hope you can follow along. Yeah, probably. So say, for example, you have two asynchronous tasks, logging in as an API and then fetching the posts for the logged in user. So what we can do with BrightFutures is return a future from this asynchronous task instead of having a completion block, for example. So when you log in with a name and a password, you get a future user. And then you can fetch posts given that user, and you get a future array of posts. And with BrightFutures, you can use flat map, the operation we just saw introduced by Ian. So when we log in, when it succeeds, the flat map closure is called, then we fetch posts. If both operations succeed, the onSuccess block will be called with posts. If either of the operations fail, you get the onFailure block is called, and then you can use the error to do something, right? So this is really nice, a few lines of code, BrightFutures. I think the equivalent with completion blocks looks something like this. I don't think I'm lying here. Yeah, not that nice, right? So from this we can see a few things that are hard work. Error handling is hard work. Asynchronous programming is hard work. Declaring data flow instead of more state is hard work. And leveraging functional concepts are hard work. So this is not a conclusive list of things that are hard work, but coincidentally, these are the things that BrightFutures is actually quite good at. So I'd like to start to talk about error handling a little bit, and then we add asynchronous programming to make it a little bit more complicated. But let's start with error handling. So this is what error handling looks like in Swift, and it also looks like this in Objective-C. It's the pattern we all know and love / hate. So we pass this in-out error parameter, but often, let's be honest, it looks like this. We just look at the result. If it's nil, it's nil somehow. And even if we pass the error, do we really pass it along to the in our own function, pass it up the chain so we can do something presented to the user? Probably not. And there's also, like in Swift particularly, there's this strong type system that we're not using here, because we have this error and the result. Nothing guarantees us that both will be nil or both will be non-nil. What should we do then, right? So we have this old way of error handling. There's no new way yet in the standard library. Oh, and exceptions are gone, but who is using them anyway? So to solve this, and I didn't come up with this, it's an age-old concept, we can use results. There are a lot of other great implementations out there. You can use those. You can also use the one from BrightFutures. It's also a monad, but don't tell anybody because that scares people away. Let's not talk about the M word. Let's just look at it. It's a simple enum, and the nice thing about enums in Swift is that you can associate types to a case. So in case the result represents a success, we can say that it has the resulting value of the known type T, because we can use generics here. We have to box it because Swift 1.2 has still some weird limitation. But trust me, there's a box in there, and inside the box there's the value. If it's not a success, it's a failure. Those are the two cases. And if it's a failure with an NS error. You know that. So if we have an operation that can fail, we can choose to return a result instead of having an error parameter. So in this case, we have a fetch products operation, and we return the result, which will be an array of products. So if we call this function, we either get a success with the array of products, or a failure with an error. Now let's look inside fetch products how we create those results. Actually pretty easy. So we have this core data code here again. And then if we can indeed cast the result of the core data operation to an array of products, we return a success, we box the products. And if there's an error, or there's no error, but there's no products either, we just return a failure state. And like with a lot of good things in life, the more you use it, the better it gets, because the result has a lot of ways to chain and compose them. So if you have write a lot of failable operations that use result, you can chain them together in really nice ways. And one of the operations that you can use for that is map. So say we have an operation called divide. It divides two integers, and it has a result. So it will either be the success, the result of the integer division, or the cannot divide by 0 failure or error. So then we can divide and then map the result of the division, and say if it's modulo 2, if modulo 2 equals 0, then we're going to that's going to be the result. So the outcome of this division mapped through this Boolean operation will be a bool, or a failure if the division fails. So now let's try to do two divisions after each other. So chain two divisions. So first we divide one number by the other, and then divide it again. We divide the outcome again. Does anybody know what the type of result is going to be? So the type of this result.
A result.
Yeah, it's a result with an int. And that's not really nice. So that's where flat map comes in handy. It really looks a lot like map, and it took me days looking at this definition to really figure it out, and then I forgot it again. Now I know, I think. So don't worry if you don't get it, but it is a way to map and then flatten out this recursion of the result in a result. So then you end up with the result int again instead of a result with result int. But if either of the two divisions fail, you still get the error in one place, which is really nice. So let's move to a more real-world example, because we're not doing divisions not that much. We're doing a lot of API calling and JSON parsing. So here we have a function, JSON from response data. It takes NS data and it returns a result of an array of dictionaries. And then we have a second function, parse products. It takes an array of dictionaries, coincidentally, and returns an array of products. You might see a lot of products in these examples. Might have something to do with that I work on a e-commerce platform. So what we can do, we can first parse the data to JSON, and then if that succeeds, use the JSON to parse the products. And then in the end, if there is a value in the result, we can use it. And otherwise there will be an error. So let's look inside parse products, because parsing products is probably made up of parsing a lot of single product objects. That's right. So we also have this parse product operation. It takes a dictionary and it returns a single product. So then we can use the Swift native map function on array to turn this JSON array of dictionaries into single dictionaries and perform this parse product operation on it. So can anybody guess what the type of parse results is? I like to play this game. Swift compiler also likes to play this.
An array of results?
Yeah. So it's an array of results with product results. And then what you can do is use a method called sequence and turn this array of product results into a result with a product array. So it will either be success with an array or the first failed product parsing. So now we have the error handling. So let's move to asynchronous programming, which is really important also because we have these really powerful phones and Apple Watches and iPads. So we really want to use it and turn our complicated tasks into small bits and execute it on any thread that's available, right? And also, UIKit would really like us to get off the main thread. And you really have to do this if you want to get the really nice, powerful user experiences that Facebook Paper, Label, Storehouse, those kinds of apps. You cannot be on the main thread. So it should be very easy to not be on the main thread. BrightFutures can help. But first, let's look at how you normally do an asynchronous operation. And I guess 9 out of 10 times, it's going to be a network operation, right? So you have this data task with URL, method, function on a NSURL session, and you pass it the URL, and then you get the completion block with data, response, and error. Probably not all of them will be non-nil, but there's really nothing guaranteeing it. So we can quickly ignore that and replace it by a result, right? So it's returning a result out of the data task with URL into the completion blocks, which looks already way nicer. Does anybody have an idea what the type of result should be here? So the result parameter. Let's go back. So here we return an NS data and NS response and NS error. So here we want to have a result with a tuple containing NS data and NS URL response. So that's the equivalent, right? So it will either be the error or the NS data and the URL response. And then we can do something with it. And let's make it a little bit more complicated. So if you have the data from the URL, we can put that into the little chain results thing we had just a few slides back. So we can parse the data into products. And now let's add something crazy. Every product has a URL. We want to fetch the content of that URL as well. And then, we want to have a lot of products and the data from their URLs. And then we would like to do something when everything completes, right? When you have everything. Well, that's going to be quite a hard completion block. You're going to have arrays, saving your completion blocks, your closures, and then counting if you have seen all the results of all the products, URL fetches. We have something better. Let's talk about future. Future is quite simple, quite similar to a result. It's actually a result from the future. So a future has a result or not. And a nice thing, the future will tell you when it has a result. So you get the future from somewhere, and then you can add yourself as a completion block, a success block, or a failure block. And then when you add yourself as a completion block, you get the result. You know how to work with results now, right? The success block will give you the actual value that's in there. You know the value. With Objective-C, you would just have the ID. It could be any object. Here it's going to be this specific type. You know it. It's great. And on failure, it's going to give you the error, of course. And we have map, flatten map, flat map for futures and flat map for results. Also really nice. So they're kind of similar to the flat map and map on a result. But if you call them on a future, it will be a vector. You don't know when it will be executed. It will be executed when the result is there. So let's look how we can turn this previous example into something more readable using futures. So we first get the data from the URL. If that succeeds, we parse it to JSON. If that succeeds, we parse it to products. If that succeeds, we will map over the return products. That's just a regular map over the array. And then we will fetch, perform a data from URL operation for every product. So that's going to return a future again. And then in the end, we want to have the product and the data together. So you probably can feel this coming. What's the type of res here? Yeah, almost. Yeah. It's going to be an array of futures of a tuple with products and data. And of course, you can sequence this just like the result. It will just be asynchronous sequence because it will wait before all the results are there, and it will turn it into a future with an array of product and its data tuples. It's really nice. And you can do something when you have all the data, or you can handle the error case and you have to inspect the error to see if it's going to be if it is because of the JSON parsing field, the data fetching field, anything. If you have it in this one nice place, and even if you don't want to have a monolithic one failure situation, you can still inspect parts of the data because you can still access the future for the first product and see if that succeeded, and if that succeeded, maybe just return that, right? So this, I hope this looks nice. And it might also look a little bit magical. So then let's talk about the origin of futures, because that might explain some things. So here we have a function that will calculate the Fibonacci number in the Fibonacci sequence. And if you ask for like a millionth number, it's going to take a while. So we don't want to do it on the main thread. So that's why we have async Fibonacci, and it will create a promise. So this is like the source for a future. And then we perform the Fibonacci sequence calculation on the global queue, the Grand Central Dispatch global queue. And then when we have the result, we give it to the promise, and the promise will make sure to complete the future so that all the completion blocks on the future will get called. And if this is too much code for you, you can also do it like this. You can just wrap your asynchronous operation in a future operation. It really looks like you add native syntax to Swift. That's really nice about having the closing and closures in Swift not to be. They don't have to be in the parentheses. It's really nice. So I have this function future. It will execute on the background thread, and it will come back to you. This unsuccess block will be called on the main thread if this slide is on the main thread, and then you can do something with it. Update your UI. So now a more real world example from the watch app that we're shipping tomorrow. You can call into the main app from your WatchKit extension using the WK interface controller open parent application method. That's going to be asynchronous, but the rest of my extension I want to work with futures. So at the fringes of your future-proof world, you will see a lot of future wrapping. So you have this Apple or third-party API using closures, completion blocks, and instead you wrap that into a future, and you can use it in the rest of your code. So here we execute. I hope it's a little bit readable. We execute the open parent application request, and then if that succeeds, we parse the result and put it in the promise or complete the promise, so that your other code can continue with the result. Another nice example is, for example, image fetcher, where every time when you perform an image fetch operation, you'll store the future in a dictionary where the key is the name of the image. And before fetching the image, you look if you already have a future for that name, and you return the same. So the image fetcher doesn't know if that future is already completed, if it's still pending, doesn't matter actually. If it's already completed and the caller of image fetcher adds a completion block, it will complete immediately, so you will immediately have the result. If it's still in progress, it will wait before it's done, fetched from the internet, and then call together with the original callers. So, and there's a bunch of stuff that I didn't talk about that's in BrightFutures. I tried to put them all on this slide. And there's more even. So you can recover from errors, so turn a failure into a success case. You can fold, you can sequence, you can traverse, you can map, you can have invalidation tokens. So if the context around your future changes, for example, in reusable UI collection view cells, happens a lot. If you scroll really fast, you don't want the asynchronous operations of the previous model in your collection view to be called when there's a new object in there. You can invalidate your completion chains. You can zip futures to combine two values when they're there. You can use the default threading model, which works pretty well, I think. But if you want to have blocks or operations execute on a particular thread, you can pass the context. So you have the global context, the main context. You can make your own context if you want. Yeah, lots of stuff. So what's the future of BrightFutures? There's going to be a 1.0 release soon, I hope. I also really like for it to be used in production. So we're shipping the WatchKit app tomorrow, and it's using a lot of BrightFutures. That's nice. There's also a separate project called Future Proofing, which contains future-based wrappers around some Apple code, so you can use, so you don't have to write them yourself. And in response to the #1 feature request on BrightFutures, which is to get progress and cancellation for futures, I've been working on a wrapper around NS progress, which is the best class that I've never used. It is great, NS progress. It's no documentation, doesn't matter. So you can use good progress. It's a Swift wrapper around NS progress. The NS progress supports cancellation and progress rate. In the future, we could combine this into some meta library, which would be nice. Yeah, that was what I wanted to tell. Thank you. Questions?
And you said if a future already happened, it will execute immediately. Is that blocking? So will that actually execute before continuing with the rest, or is that like immediately but at the next run?
That depends on the context that you pass to when you add the completion or the success block. By default, it will execute on the main thread, but there probably is one run loop cycle after. There's a lot of dispatch async in there to prevent deadlocks, which is nice to prevent deadlocks, but I would like there to be less, but I'm not sure if that's possible, if it's usable. So by default, it will execute on the main thread with one run loop cycle further. You can also pass the immediately executing context, and then it will do it immediately without any dispatch async.
What's keeping you from version 1.0?
A little bit of time to wrap everything off.
It's shipping, so it is 1.0.
Right.
Yeah, it's 1.0.0 dash beta 6. So yeah, we're almost there. But it's a bit scary to put out 1.0.
Just do it!
Yeah.
Do it now! Do it now!
Now. Keep on writing.
Oh, thank you. Maybe later this week.
In the future. So you showed the example of a success wrapper for an array of things, and then if one of those fails, it goes into the failure block, and then you say, okay, well maybe you want to recover from that if one of those succeeded. Yeah. Is there like a syntactic sugar or something to do that easily? Like say, I don't want to sequence, but I want to I want something back, and I don't care if anything failed.
So there's this method that returns the first future that succeeds given an array of futures. So you could do that every time, and then every time when the future...
So you get a callback every time?
No, you get it for the first one, but then you could add another callback for the remaining array, maybe something like that.
Yeah.
And otherwise, it might be easy to make. Or you could fold the array of futures and then use the first one that's not failing and pass that along.
Yeah.
Are you considering throwing this all out and moving to the active program?
That's a good question.
I think there is probably a future framework somewhere in there, down below.
Yeah, I think to be honest, you can do most, if not all, of the BrightFutures things with Reactive Cocoa.
Is this more low level?
Yeah, so Reactive Cocoa is about 10,000 lines of code. This is less than 500. So it's completely different.
I think this is far more likely to be allowed to be used on a client project as well. There's not much chance you're going to be allowed to use Reactive Cocoa because it's so hard for any other programmer to get their head around it. Unless they really study it, then the client isn't going to let you use it. But maybe this they would. Right? So
there's one big difference. There's one big difference between reactive and futures. That futures will return one value, and the reactive streams will return any amount of values and then complete.
Yeah.
So that's a bit of a different use case.
Yeah, so Reactive Cocoa, that's great for view models and stuff, and BrightFutures won't be that great for view models where you have constant streams of changing data. Right? I think futures are a great candidate for a background task or one-off task when you're launching a view or data requests or any of those kinds of tasks. Yeah.
So
Are there sort of specific areas where you're worried or can completely rule out that deadlocks and light locks can occur? And related to that, sort of like what you sometimes see in techniques like this, that on top of the Fibonacci sequence or otherwise, when everything completes, you sort of like get an avalanche or sort of like a waterfall of basically completion events, which then basically blows out your level 3 cache or whatever it is, and you don't have a light lock that finishes grind to a hole. Is that something you can prevent, or you can mathematically make sure that doesn't happen? Or
So that would, so then your stack would get out of sight. Yeah. So that's a downside of reactive code. Would also BrightFutures that sometimes your stack traces are not very easy to read. There's going to be a lot of future completing. That's a downside, and Swift has a lot of abstract chunk block themes that I don't understand.
But what is the limit? Do you know like how many? Like what would the limit be? Yes. Is it like hundreds or thousands or millions? I don't actually know.
Certainly not the many thousands, but
No.
not on millions.
I know that, for example,
Oh yeah, that's a contract example. Like the Fibonacci stuff, if you 10,000,
Right.
that's not fair.
in Objective-C we're using Facebook bolts. They have this BF task framework, and I know that they, if the stack gets too deep, they will do a dispatch async. And so then
But it could work also like at some point catching that, for example, going through a linked list, basically going into a linked list or something like that.
no, I haven't explored that.
In your result type, you're using for the failure case an NS error. Did you consider using a generic type there?
Yeah. So there's this great result micro framework by
Rob
Riggs. Yeah, and that one uses two generic parameters, one for the success value and one for the error. I think I like it, but I also like that the definition of a future now is really small. So that would also make the future have two generic parameters probably. I'm not ready for that.
I find it kind of interesting because in the new PostNL app that we developed, we quite used the same structure as you're presenting right here. And we're now running in a little bit of trouble with the untyped errors.
Yeah.
Because sometimes somebody is forgetting to flatten that to a function that does some error handling for us. And if we type the errors, that could be prevented by typing each error differently, like using an NS error and like a PostNL or an app error.
I've used that kind of structure in my own code, and then you run into some problems where you have like you have a result type of a certain data value, and then you have an error type, and you really don't care about the data type, but you know the error type, and then you need to convert this data type that you don't care about to, or this result type with data type, an error type that you care about, data type you don't care about, to another result type of another data type with the same error type that you do care about, and you're just juggling with types to just keep the Swift compiler happy. So it isn't all beneficial, but it's tricky.
Yeah, I could add that I only use NS error as a vessel for the error. In the other code, I have like an enum with all the possible errors, and that enum knows how to turn itself into an NS error, and then I use that inside futures or wherever.
Do you want to go into why the box thing? Or do you really not?
Yeah, it has to do with that
why.
the Swift compiler is not able to produce machine code or intermediate code for variable layout enums. So if you have an enum with type T, you don't know what type T is, it doesn't know how many memory to address for a T, I think. If you box it, it's always going to be a pointer size, because it's going to point to something else.
Okay.
Yeah, that's. I was really hoping for them to fix it before 1.0, and now at 1.2. So I guess it's not that high on there.
It's a feature.
Yeah, everybody.
It's a feature.
It is saying unimplemented feature, right? The compile error is saying unimplemented feature, so they are aware that
First it crashed, and now it says not yet implemented.
Okay, thank you very much. So,